A very good day to Dr. Nadia and Dr. Adru. Today, our group is going to present our project, which is Project A. My name is Mo Sheng Han. Our group consists of 3 members. Now, I will show our base model. There are 2 production lines, which are production line A and production line B. Production line A will produce X1 and X2, while production line B will produce X3. There are another external supplier who supply X4. We use transport forklift to transport our product to assembly station. There will be 50% defect rate for line B and 5% defect rate for assembly station. Now I will run our model. So now finish running. So as you can see, our finished product is 355 and our rejected product is 19. So according to the question, X1 doesn't skip process, but X2 skip drilling process. In order to do that, we actually need to setting at milling, and we apply the skip drilling method into controls. So this is our skip drilling method coding. So now I will show you. So as you can see, for the drilling, there is always only got the X1, and the X2 will straight away skip to buffer 3. Okay. So besides, we also do a buffer for line A to separate the X1 and X2 to make sure that there are 10 product each. 10 product for X1 and 10 product for X2 while going to the assembly station. So now I'll move to verification. There are a few aspects to verify, which are working shift, operating and material cost, processing time, defect rate, and amount of item transported to the assembly station. So firstly is working shift. So we adjust a working hour according to the instructions and also the resting period. So secondly, we apply a cost for operating cost, this is the milling operating cost, and the material cost. So actually we can know the total cost at the HTML report. We show report. So we can know that the total cost is 66 ringgit. Okay. Another one is the transporter line. So for transporter line A can only transport 20 items each time. So in order to do that, we replicate 20 times for the coding. Same goes to the unload 20 times. So now I will show you the so after one time, as you can see, that is 10 x1 and 10 x2. So total is 20. So same goes to the transporter line B, which can only transport 2 items. So we do 2 replication of coding. Okay, so for the line B, there is actually 50% defect rate. So we adjust it. We setting here 50-50. So for assembly line for 5%. So we set it the same way. So the lower is the defect, the upper is the good product rate. Okay, that's all for verification. So now we'll move to validation. So validation mostly is the calculation. So we do 6 replication. We take 95% as the confidence interval and 0.05 level of significance. So this is the step 1 to get the average. So the step 2 is to get the sample variance. So for the step 3, we get the t value, two tail. So lastly, we get the lower and upper bound value because we use the two tail table. So last but not least, the hypothesis is the real system average 349 throughputs fall outside the range of the 95% confidence interval with 6 replication, which is between 344.75 and 353.243. The best case error is 353.243, which is higher than 349, so the model needs to be refined. The worst case error is 344.76, which is smaller than 349, so accept the model. That's all from me. Thank you.
Hello, my name is Wang Longxing. I would like to present the improved model part based on the base model. For the improved model 1, the inter-arrival is reduced from 5 minutes to 2 minutes. Operation cost can be reduced when the forklift is replaced by the conveyor. This is because less worker will be needed to drive the forklift and the maintenance will be reduced. The working shift is changed to the standard working time, which allows the worker to rest 50 minutes every 5-hour working time. The throughput for this model is 500. This is the simulation of the improved model 1. As you can see, the conveyor has replaced the forklift so it doesn't have to go back and forth every time. For improved model 2, inter-arrival time is reduced from 5 to 2 minutes. Same as the improved model 1, conveyor is used to substitute the forklift. The working shift is also used to change the standard working time, which will improve the worker condition and productivity will also be increased at the same time. Buffer is added after the assembly station to smooth out the entire process. Besides, the processing time in the normal distribution in the assembly station is also reduced from 1200 300 to 120 30. The throughput for this model is 503. This is the simulation of the improved model 1. As you can see, the conveyor has replaced the forklift so it doesn't have to go back and forth every time.
Assalamualaikum. My name is Nursalvina Binti Kamaluddin. So I'm going to explain about the improvement model design 3. So this is our improved model 3 design. As you can see, there is a total of 4 production line for part X1, X2, X3 and also X4. So the parameter that we change or replace in design 3, first is the working shift. We change to standard operator working shift to 12-hour system working like other company. This is to increase the production line output with longer working time. And secondly, we separate station from production line part X1 and X2 to smooth inspection line if either of the two parts does not arrive at the assembly station. The third parameter is we remove buffer at the production line part X3 to reduce costs in maintaining the stations and also to simplify the whole production line for part X3. And the fourth parameter is we replace the forklift with conveyor to smooth the production line with continuous part transfer without worrying or calculating the back and forth transporter time. And lastly, we're reducing the rejected part ratio in production line part X3. This is one to increase the part X3 that are in good conditions, which helps in making the increment of the final throughput A1. Okay, so according to the improved model 3 model, there will be a total of 4 lines, X1, X2, X3, and X4. If I play the simulation in a slow pace, the part will go to the conveyor, directly to the conveyor and go to the buffer, and then it will be make sure for all the 4 parts is arrived at the buffer before go to the assembly station, and then lastly go to the drain for the good product A1. So if we finish the simulation, we get the final throughput of 504 with the rejected part product A1 for 27 and rejected product for X3 is 143. So this is the resource statistic for improved model 1, model 2 and model 3. So this is the summarization for the resource statistics. The improvement model 3 has both highest machine utilization percentage and waiting percentage, and improvement model 1 has the highest blockage percentage. And our group chose improvement model 1 as the best model design, as it is the model that achieved the 500 production target solid. And the second reason is we maintain the existing model design, except we just replace the forklift with the conveyor, so it does not require us a lot of cost in adding any of the station. And the third reason is we replace the transporters with conveyors in order to save costs in using labor for transportation like existing model, and the process can keep continuous instead of taking time to go back and forth if using the forklift. And the fourth reason is we use the standard working time operation hour like the other company, which is a 12-hour system. And not to worry, we set the time by following the Employment Act 1955. And for that, that's all from our group. Thank you and Assalamualaikum.